It's another Mate here with teacher Jenny. Join me for another topic. This time we're going to talk about infinite limits and the other theorems. We have the infinite limit theorem. So when you have there a limit of f of x as x approaches a, a number, as x approaches a, that will be equal to c, which is also a number, which is not equal to a 0. So meaning to say the limit of your f of x as your x approaches a will never be a 0 or cannot be a 0. And the limit of g of x as your x approaches a is equal to 0. Then once you are going to find the limit of your f of x over g of x as your x approaches a, that will be a positive infinity if our c is greater than 0 and g of x approaches to a 0 coming from the right side. So meaning to say, once you are going to get the limit of your g of x, the limit there of your g of x is a positive, then you will have a positive infinity for that one. So the reason there why your f of x or the limit of f of x as x approaches a cannot be a 0, because that would somehow lead to a 0 over 0. Because if you try to look at this, once your limit of g of x as x approaches a is a 0, so you will have there on the g of x is 0 on the limit, and then your f of x there is a 0. That will lead to an indeterminate. So that means to say we can do something or manipulate our function there. So that is why it's a no-no that your limit of your f of x is a 0 for that part, for this particular theorem. Now, so meaning to say we've got a value here which is a c. So that c, once c there is greater than 0, meaning it's positive, and then you have there the limit of your g of x is also approaching to a positive, is going to be coming from the right side of a 0, meaning to say it's also a positive, then we have there a positive infinity. Or once you have a c which is less than 0, meaning it's a negative, and your limit for the g of x there is going to be on the left side of your 0, meaning it's negative, then you will have there a positive infinity. Now, you've got their limit of f of x as your x approach over g of x as your x approaches a is equal to a negative infinity if your c is greater than 0. That means it's a positive. And the g of x there, once we try to get the limit of that one as to whether it's coming from the right side or left side of your approaching value, is going to be coming from, the result is going to be coming from the left side of your 0, meaning it's a negative value, then you will have a negative infinity for that. Or if our c is less than 0, it's a negative, and then you've got there the limit of your g of x. Once you try to get the limit of your g of x by simply getting values coming from either left or right side of the approach value, the result there is from the right side of 0 or positive, then we will be getting a negative infinity for the limit. So let us try to put that one in a picture. Let's try to have an example here. So basically, if you try to look at that, they have the same sign here, positive, positive. That's a positive infinity, negative, negative, negative. That's a positive infinity, sorry. And then once they don't have the same sign here, that means to say that we have a negative infinity for that one. So let's start with the example. So once you say limit of 2x plus 1 over x minus 3 as your x approaches 3 coming from the right side. So basically you can do it like at the top, because we don't have a problem with the top one. We can just simply plug in or substitute the value which we are approaching to with, like we've got here 2 times our x will be a 3 and then plus 1. So at the bottom part, because once you try to plug in 3 here, that will become a 0. This is what we wanted based on our theorem here, that our g of x part here will become, or the limit of the g of x here will become a 0. So if this is gonna be the case, instead of plugging in 3 here on x at the bottom part, we will be getting a value as to what is indicated here on the approach value. So since we have here x approaches 3 coming from the right side, if this will be our number line, this is 3. What is coming from the right side of 3 is the number 4. As we move closer, we'll be choosing a number which is very close to our 3, and that might be a 3.1. So we can have a 3.1 there. So we need to say we are trying to get a 3, or replace x here, but not 3, but 3.1. So trying to do that one, let's try to simplify that. So we have 2 times 3. That will be a 6, and then plus 1 over 3.1 minus 3, that will be equal to 0.1. And then we have 7 divided by 0.1. That will be equal to a 70. Now, if you wanted to try to check the other values, like if we try to move closer more to our 3, we can have it as 3.01. So let's try to redo that and try to check what will happen to our value of the limit once we try to change our value of x moving closer to our 3 coming from the right side. So here we've got 2 times x plus 1. What we are going to do to simply, on the numerator, is to simply substitute the 3 there. So we've got 2 times 3 plus 1, because we don't have a problem with that one. The only problematic thing here is the denominator, because that leads to a 0. So we'll be getting more numbers. So we'll be having 3.01. That will be more closer to 3. And then we have minus 3. And then this will be a 7 based on the computation above here, over 3.01 minus 3. That is a 0.01. So dividing that one, we have 7 divided by 0.01. That will be a 700. So the more you add zeros in there, or the more you move closer to your 3, this will be coming bigger and bigger on the positive direction. So once you say limit of the 2x plus 1 over x minus 3, as your x approaches 3 coming from the right side, that is a positive infinity. So that is what we meant on the theorem there. Another one is when you have the limit of 4 minus 3x over x minus 7. As your x approaches 7 coming from the left side, so all we have to do is to simply plug in at the top. So we have here 4 minus 3 times your x, which is 7. And then over our x, we can just simply get an x here. If we try to plot the number line, 7 is here. This is coming from the left side because we have negative in here. So from the left side on that one, we've got a 6. And then once we move closer to our 7, we've got the value here as 7.9. I mean 6.9, sorry. Okay, there's 6.9. So we will be replacing our x here by not 7, but by 6.9. And then we try to subtract that one by 7. So we'll be simplifying that one. So we have 4 minus 3 times 7, that's a 21, over 6.9. 6.9 minus 7, that will be equal to a negative 0.1. And then we try to simplify further. This is 4 minus 21, that is negative 17, over negative 0.1. So notice you may not go further for that one, because based on this one, you can clearly see that this will lead to a positive value. So automatically out from the picture there, we've got negative over a negative that would lead to a positive. So we can just simply skip on the continued process on that one and go directly to our generalization that this one here is a positive infinity. So this is positive infinity. So you may do that one. As long as you've seen that the C part there is negative and then the lower part is a negative, then you can just simply directly go to a generalization or to your conclusion that that is a positive infinity. Okay, the next one here is the limit of your x minus 2 over x squared minus 4x plus 4 as your x approaches 2 coming from the left side. So if you try to substitute this one, you will have here x minus 2, x is 2, minus 2. Notice that that will become a 0. Let's try to examine because in our theorem, we cannot have a 0 at the top. So let's try to examine if we can, or if the bottom part here is a 0 as well, because once you've got a 0 over 0, we can manipulate our function. So checking that up, we've got here 2 squared minus 4 times 2 plus 4. So simplifying that, this is 0 over 2 squared is 4 minus 4 times 2 is 8 plus 4. This is equal to 0 over 4 minus 8, that's negative 4 plus 4, that's a 0. So see, that's a 0 over 0. Since that is the case, we are going to do manipulation here. So let's try to manipulate. Let me just erase this. Okay. Manipulating this one, that would mean we can do something on our function. Let me just have it like limit of x minus 2 over x squared minus 4x plus 4. This is trinomial, and if you try to look at this, we have here a 4, which is a perfect square. X squared is a perfect square. Checking whether this is a perfect square trinomial, we just get the square root of our 4 and square root of x squared here and multiply the 2 and twice that one if that is the middle term. So square root of 4 is 2 and then square root of x squared is x, and then multiply that by 2 to check whether this is the one in the middle here. So this is 4x. So that means to say that this is a perfect square trinomial. Or you can just do the way how we factor our trinomial here by simply getting the factors of 4, in which once you add the factors that will lead to a negative 4, that's really fine. Here we've got x minus 2, because that's a perfect square trinomial. We just have to get the square root of the first term and the last term, and then we copy the sign of the middle term. So we have square root of x squared is x, square root of 4 is 2, and then we have a minus sign in the middle. So we have x minus 2 and another x minus 2 here. Or you can have x minus 2 squared as your x approaches 2 coming from the left side. So this can be canceled. So we've got now the limit of 1 over x minus 2 as your x approaches to 2 coming from the left side. So starting off from here, we can simply substitute that one. So we've got limit. If you try to look at this, this is 2 minus 2, that's a 0. So that means to say that we need to identify whether we have a positive infinity, negative infinity, or a DNE. But then again, this is with this is one-sided limit, so this is coming from the left side. So basically, we'll just have either positive infinity or negative infinity. So let's try to get a number from the left side of 2. So if this is the number line, you've got 2 here. Left side of that is 1. And then this value here could be a 1.9 or 1.99. So you can actually choose between those values as long as it's closer to your 2. So let's have now plug in to your x the value 1.9. So this is now equal to 1 over 1.9 is your x, and then minus 2. So simplifying that one, we have 1 over 1.9 minus 2, that is negative 0.1. And then dividing 1 by negative 0.1, that is equal to a 10, negative 10. So our limit here, or if you try to look at that one using our limit rule, if you just try to recall, this is an odd exponent on your x here. But anyways, let's just go directly to what we've known. So this is 1 over negative 0.1. So no matter what will be the value of your x there being replaced at the bottom part, may you have negative 0.1, negative 0.01. This would lead to a bigger negative numbers, but not in values, although. So we need to say it will be becoming bigger on the negative side there. So that means to say that we have to move towards a negative infinity on the limit of this. So the limit of your x minus 2 over x squared minus 4x plus 4 as your x approaches 2 coming from the left side, that is a negative infinity. So that is how we get that the limit of that. Next, we have here the limit. This is going to be the last one. The limit of your x minus 4 over x minus 1 as your x approaches 1 coming from the left side. This is now going to be, we can apply our limit laws before, once you have their subtraction. So we can just simply distribute our limit here on your two terms. So we have limit of x as your x approaches 1 coming from the left side minus our limit of 4 over x minus 1 as x approaches 1 coming from the left side. So this is now our limit of x coming from the left side. We can simply substitute our value here on x. We have that as 1 and then minus, because we don't have a problem of that one coming from the left side and right side. We still have the value, which is a 1. And then we have minus a limit of, but then again, we're getting values from the left side of this that might lead to confusion later. Sorry. X, as x approaches from 1 coming from the left side. So meaning to say, once you try to plug in values that are closer to 1 from the left side, that would lead to a 1 as well on the limit. Now, minus the limit of your 4 over x minus 1 as x approaches 1 coming from the left side. So if you try to plug in your x here with 1, this would lead to a 0. So that is why all you have to do is to just get a value coming from the left side of your 1. So we can have there, if this is the number line, this is 1. From the left side of that, we've got a 0. So as we move closer to 1, this is going to be a 0.9, or you can have a 0.99 in there. That's really fine with me. So I'll be choosing 0.9 here minus 1. So this is now 1 minus, let me just erase the limit here, because once you try to substitute, automatic that will be without a limit already. But basically, let me just have it here because that might be leading to a confusion later on. Let me just pull out the limit of 4 over x minus 1 as your x approaches to a 1 coming from the left side. So this is now 4 over 0.9 minus 1. So this is 4 over 0.9 minus 1. That will be negative 0.1. So this is now negative in here. So once you try to divide that one more, this will be becoming a negative. Or if you wanted to change this one, if you wanted to have a 0.99 in there, this will still be a negative in here. So most likely this is approaching to a negative infinity value, because as the more you add zeros in there between that one there and the dot, that means to say that you will have there a bigger number, but only that negative. So that means to say that that is moving towards a negative infinity. So if you try to plug this one in here, 1 minus a negative infinity, there, that will lead to a 1 plus infinity. So this will be now leading to a positive infinity. So that is now the limit of that one. And that's it. I hope that you've learned something from me. This is again your teacher Jenny saying good luck on every challenges in your life, and always remember that every day is a new day.